Okay, a little homework help. Let's see. What volume of 2.5 molar lead nitrate solution? So lead nitrate. It's always good to write out the compound. So it's PbNO32. Contains 0.050 moles of lead ions. So the concentration they give is for the whole compound, but they're asking about for the lead ions. It looks like it's 1 to 1, right? So this is going to dissolve 1 to 1, Pb2 plus and NO3 minus AQ. You get two NO3s, but they're asking about the lead, so it's 1 to 1. It's one lead for every one lead nitrate that dissolves. The other thing about this, the molarity is moles per liter, and they're asking, that's actually the given. I'm sorry, the what you're looking for is liters because they're asking about what volume. So you need to like invert this conversion factor. So we're gonna go 1 liter of 2.50 moles, and the substance they're describing is lead nitrate. It's dissolving 1 to 1, so that's this right here. One of those for every one of those. The coefficients are moles, so you need to be writing mole. So 1 mole of lead ions is produced for every 1 mole of lead nitrate. So 1 mole of lead nitrate. This step needs to be shown, even though it's 1 to 1. It demonstrates that you understand this really, because it's not always 1 to 1, right? So those cancel. And it's saying how much volume has 0.050 moles. So we're going to use this to cancel out this conversion, this unit. So we'll put 0.050 moles of Pb2 plus here. So those two cancel. All right, so that's A. For part B, how many milliliters of 5.0 molar potassium dichromate must be diluted? So these are the diluted amounts. So that's giving you the diluted amounts, and they want to know how many milliliters of the concentrated and how many milliliters of the concentrated. So we're trying to solve for V concentrated. And these are the diluted amounts. So we're trying to solve for the concentrated volume. So M diluted, so 250. Always write your units if you're using a formula in this class. It's a really easy way to double check that you're solving for what you're trying to solve for. So and besides, it's asking for how many milliliters. So you could see if we leave everything in milliliters, the molarity unit cancels. 5.0 molar. I wanted to point out on this first problem, I did the style, the method where you start with what you're trying to solve for. Okay, so I saw that it was asking for volume, so I started with volume in the numerator. You could actually, if you did this all like completely in reverse, that's totally fine too. So you could use this as the final conversion step. Those were the two methods I showed in class. All right, so a little help on the last one. Mixture. What's the final concentration of K plus ions? So the final concentration, it's always good to write an expression for the final thing you're solving for. final concentration. So what are the units for concentration? It says, and we see that it's a mixture. So you have two sources of potassium. So it's going to be the total moles, which are going to be additive, total moles of K plus over the total volume. So if you leave, this is in milliliters, this is in milliliters. The total volume, we can see that it's 75.0 milliliters. So we're good on the denominator. We just have to get the top here, total moles of potassium. So it's going to be 40. So I'm going to leave everything in milliliters in the top, because if I have milliliters in the bottom, it should work out. So 40.0 milliliters times, so I want total, I'm going for total moles. So 40.0 milliliters times 0.15 moles of KClO3 per liter. And I know that this doesn't cancel, but I mean, I know that ml is going to be on the bottom, so it'll take care of that. And my final unit is going to end up being moles per liter. So you'll see. Besides this is something I know this familiar with. This is actual unit. It's called a millimole. If you multiply a milliliter times a molarity, it's called a millimole. It's an actual thing. All right, so 1 mole of K plus over 1 mole of KClO3. This step's important because, as you'll see, it's not 1-to-1 for the other substance. The other substance is 2. You get 2, so K2SO4 is going to make 2 moles of K plus and 1 mole of sulfate ions. I'm gonna kind of work sideways here, so I'm gonna put it here. So we have 35 milliliters times 0.22 moles per liter of potassium sulfate. That's an L, that's not a 2. And then you get 2 moles of K plus per 1 mole of K2SO4. Okay, I'm going to take all of that and I'm going to divide it by 75 ml. We're going to work on a few more in class to get some more practice in tomorrow. Good luck.